Alright, so in this video we're going to start introducing some concepts about electrical forces and fields. The first thing we'll do is we're going to study Coulomb's law. At this point we're already assuming that you are familiar with the fact that there are two kinds of charges. There are positive and negative charges. You know what your electrons and your protons are. You also know your methods of charging, that you can charge an object by contact called conduction, and you can charge an object without contact called induction. So make sure that you're familiar with all those ideas, also with the concept of polarization and all that. So at this point we know that there are these things called charges, okay, and that charges exert forces on each other. Alright, now what we're going to look at some of the properties of these forces. Alright, so let's say that I have a charge. Let us say that we don't really know what kind of charge it is. Let's say that we just have a charge. We represent charges with the letters Q1, with the letter Q. So we're going to just give it the subscript Q1, and then similarly Q2 for the second charge, and let us say that they are separated by some distance r. Okay, what we know is that the force that these two charges exert on each other is always along the line joining the two charges. Okay, these forces could be attractive or repulsive depending on the nature of the charge, which means if Q1 and Q2 are both positive, then the forces will be along the line, okay, pushing each other out. If they are positive and negative, these forces will be attractive along the line. So essentially, the direction of the force will be governed by the sign of the two charges. Okay, Coulomb's law gives us the magnitude of the field and the magnitude of the force. Okay, and when I write magnitude, I can put my absolute value sign, is equal to K sub E times Q1 times Q2 divided by R square. And this is the same as the magnitude of the force on 2 due to 1. Okay, here K sub E has a value of 9 times 10 to the 9 Newton meter square per Coulomb square. But K sub E itself actually comes from another quantity, which is 1 over 4 pi epsilon 0, and the epsilon 0 itself has a name. It is called the permittivity of free space, and it has a value of 8.85 times 10 to the minus 12 Coulomb square per Newton meter square. Now I've been mentioning coulombs, and what we do is we measure charges in units of coulomb. So Q1 and Q2 are charges measured in coulombs. Okay, capital C. Now there are a few things that one must keep in mind. First of all is that when we find the magnitude of the force, you will ignore all signs. Okay, so just make a note of a few things. So for magnitude, so magnitude of force, okay, ignore all signs of the charges of the Q's. Okay, you will use the signs to determine the direction appropriately. Okay, now let us look at this simple problem here. We'll take care of this. Okay, so in this problem, what you have is you have two charges. Say a charge of 10 microcoulomb and another charge of minus, say, 8 microcoulomb, and let us say that they are separated by a distance of 0.25 meters, and we want to ask, find the force on the negative 8 microcoulomb charge. Okay, so when we say force, we always mean magnitude and direction, so make sure you keep that in mind. Okay, so let's go ahead, let's write the equation out, and the force, I'm just going to call the force F. I'm not going to put F1, 2 and all that, so we can just call the force F. Okay, it will be given by K Q1 times Q2 divided by R square. But keep in mind, we'll ignore the signs. So it will be 9 times 10 to the 9 times 10 times 10 to the minus 6. Oh yeah, I gotta make a note here. Okay, 1 mu, okay, is 1 micro. That is equal to 10 to the minus 6. So keep that in mind. So unit that we'll use. So it's 10 to the minus 6 multiplied by 8 times 10 to the minus 6 and divided by 0.25 square. Okay. So when you calculate this, you end up getting 11.52 newtons. And we also ask the direction of the force. Now the direction can be obtained very easily, but for some reason, this ends up becoming a huge issue when people are trying to figure these things out. So here's what you have. You have a charge, the first charge and the second charge. You have the first charge is a positive charge, the second one's a negative. And we're asking what is the force that is experienced by the negative charge. So what you want to do is go set at the location of this negative charge and ask what is the positive charge doing to it. Okay, and in this case clearly the positive charge is pulling it, it's attracting it, so it's pulling it to the left. So the direction of the force will be to the left. Alright, so that is one problem. Hopefully you understand all the basics here, and in the next videos we'll look at more complicated cases.